Based off the rate that it gives us, rate of formation, C is a product, so it's forming molar or moles per liter. Calculate K. That's not too bad. We love to plug and play. All right, they give us the rate loss. We just the rate. I'm going to plug in right there where it says rate. Concentration of A. I'm going to plug in right there where it says concentration of A, and then concentration of B. I'm going to plug in right there. So let's do it. 0.048 molar seconds to the -1. Well, that's going to equal K, which is what we're solving for. It says calculate the value of K. A is 4.0. That's molar concentration, and that's second order with respect to A. So we're going to square that. 1, let's calculate for K. All the stuff on the right side is just going to be 16 because 4 squared is 16 times 1 is still 16. All right, and that's going to be molar 3 of those. I do that same thing for the other side, and all of this stuff is gone. All right, the molar on the top is going to go away, and that's going to leave us with 2 on the bottom. Let's punch this in a calculator, and does this go in nicely? It does go in nicely. 16 goes into 48 3 times, and then we're going to have to move that properly. 0.003. What units do we have? We have moles per liter, 2 of them, so I'll just do moles per liter to the -2 on the bottom, and then times, that's also seconds to the -1. Let's rewrite this scientific notation. We need 2 sig figs, right? So 3, 1, 2, 3. We're moving it over there. 3.0 times 10 to the, we just moved it 3 times to the right, so we had to times 10 to the -3 moles per liter to the -2 seconds to the -1, and that's all equal to K. As this trial runs, the concentration of B decreases. What did it decrease from? Let's find that out. B, all right, B started at 1 moles per liter, 1 moles per liter. So the concentration of B started at 1.0 moles per liter, and it decreased to 0.4 moles per liter. So what is the change in the concentration of B? Let's figure that out. All right, well, final minus initial, that's going to be -0.6. It decreased by -0.6 moles per liter. So what's the relationship with reactant A? Well, reactant A is getting used up twice as fast as reactant B. So twice as fast. So for reactant A, all right, well, in the same amount of time, it has gotten used up 1.2 moles per liter, or molar, has gotten used up. Now, what did it start at? A started with a concentration of 4 moles per liter. Started at 4 moles per liter. So initially, the concentration of A, initial, right, started at 4 moles per liter, and it went down as we just 1.2 moles per liter, and so we have 2.8 moles per liter.